Uh, Hello everyone. Today our topic is about isotopes. Okay, so our new lesson, very important, and from exam point of view as well, and from daily life as well. Okay, so isotopes, you may have heard the name before, that it can be defined the atoms of element having same atomic number or proton number. Okay, because atomic number and proton number are same but different mass number or nucleon number. So the isotope can be defined as the atoms of the element having same atomic number but different mass number. The different mass number is due to difference in number of neutrons. Okay, so the different mass number is due to different neutron number present within atoms of same element. So some elements of the same some atoms of the same element change in the number of neutron would cause the atoms to have different physical property. Okay, so the different mass number is due to different neutron number present within the different within the atoms of same element. Okay, so the atoms having different neutron number would show different property. So after, the important thing related to this is that the isotopes they may their chemical properties are same. Okay, chemical properties are same, it does not change. Okay, but the change is in the physical property. So physical property is brought in physical property. Okay, change is brought in physical property like density, okay, like radioactivity. Okay, so the chemical properties are same. Why the chemical properties are same? Because the chemical properties depend upon the number of electron. Okay, so if the chemical properties so if the number of electrons are same, or the atomic numbers, okay, if the atomic number of the atoms or the number of electrons are same within the atom, it will show the same chemical property, all the atoms, all the isotopes of the element. Okay, but change is brought in physical property like density, like radioactivity, density or heaviness. Density means heaviness. Okay, why? Because the physical property here, this physical property, it depends upon the mass number of the atoms. Mass number, it defines the physical property of the atoms, while the atomic number, it specifies or it describes the chemical properties of the atoms. Keep in mind this point. Okay, so chemical properties does not change. Why? Because the number of electron remain the same. Somehow physical property they are showing variation, they show difference. Why? Because the mass number does not change. The mass number is changed because the mass number is changed because the number of neutron, it is changing. Okay, Other thing is that the density, okay, or the heaviness. For example, there is an isotope like chlorine 35 and 17, and there is chlorine 37 and 17. So there is mass number is 37. Here mass number is 35. So this chlorine, it is more heavier. It is more heavier and its density is higher. So its density would be greater or higher than as compared to this chlorine. Why? Because its mass number is 37. Okay. In the same way, this chlorine atom might also be radioactive. Okay. And I will tell you that how atoms become radioactive. Okay. So after this, let me describe you this radioactive property of element through example. For example, this is hydrogen. Okay, this is another hydrogen. Hydrogen have 3 isotopes. Okay, 1, 2, 3. Now this hydrogen, which is also called common name is hydrogen. This hydrogen have 1 electron, 1 proton, and no neutron at all. Okay, so it means that mass number is 1 and atomic number is also 1. Is that clear? And its percentage is 99.99%. Okay, this percentage on Earth. This percentage composition is on Earth. Okay, so on the other hand, if you see this isotope, its name is deuterium. Deuterium. This isotope of hydrogen have 1 electron, and in the same way it also have 1 proton and it have 1 neutron. Okay, it have 1 neutron. So as a whole, if we find the mass number of deuterium, mass number would be 2, because 1 proton, 1 neutron in the nucleus, and its atomic number would be 1, because its proton is 1. Okay, so this is its nucleon number. If I draw the structure of deuterium, here you will see 1 proton and 1 neutron and 1 electron revolving around the nucleus. Is that clear? So here neutron number, there is 1 excess particle, 1 extra particle inside the nucleus of deuterium, and that is neutron, no charge. Is that clear? So number of neutron has brought change in the mass number. Number of neutron, change in the number of neutron has brought change in the number of mass. Okay, so mass number got changed because of the neutron. So, and it is 2. Okay, and so we can say that the nucleus of this deuterium, it becomes heavier as compared to hydrogen, because here hydrogen, it have only 1 proton and 1 electron. Only 1 particle inside the nucleus, 1 particle. Okay, but here there are 2 particles inside the nucleus. Okay, its nucleon number is 2. Is that clear? But here 1. So here we can say that deuterium is more heavier as compared to hydrogen, or we can say that density of deuterium is more as compared to hydrogen. Is that clear? On the other hand, if we compare the if we see this the name of this is tritium. Okay, this isotope of hydrogen, it consists 1 electron, atomic number is same, 1 proton. Okay, but here 2 neutron are present. So as a whole, if we see the mass number, it is 3. Okay, 1 proton plus 2 neutron is equal to 3, and atomic number is 1. Atomic number is 1. Okay, so if we draw the structure of the atoms, okay, if you draw the structure of the tritium, you will see that inside the nucleus there are 1 proton and 2 neutrons. See this tritium, it consists 2 extra neutron, means that inside the nucleus of tritium there is 2 extra particles. So definitely the nucleus become more heavier as compared to hydrogen or deuterium. Okay, so its mass number is 3, means that its nucleus is 2 times heavier than hydrogen and 1 times heavier than deuterium. Is that clear? So so keep in mind this deuterium, which is heavier, and tritium is the heaviest isotope of hydrogen. Okay, and and its density is also more heavier than deuterium and hydrogen. Okay, keep in mind that the percentage composition of deuterium is almost 0.01% on Earth, and it is found in very small traces. Okay, very small traces, and this tritium is found in very small traces, very negligible amount on the surface of the Earth. But this tritium is found in universe. In universe, it is found almost 90 to 99%. Why? Because the stars and the sun, this consist greater amount of deuterium and tritium. The stars and sun consist deuterium and tritium in large amount, up more than 90%. Okay, but on Earth, this 2 isotope of hydrogen is present in very small traces. Okay, in very lesser amount. Okay, another thing related to the nucleus, as I told you that the nucleus of over there, it becomes heavy. Okay, keep in mind that when the nucleus, okay, it becomes heavy. Okay, when the nucleus becomes heavy, what will happen? That it will become unstable. Okay, when the nucleus becomes heavy, it will become unstable, and as a result, what will happen? Because of instability, it will emit radiations. Okay, it will emit radiations. So whenever an atom emit radiations, okay, when an atom emit radiations, that atom is called radioactive. Why? Because it emits radiation by its own, automatically. Is that clear? Why they emit radiations? Because of unstable nuclei. Because of unstable nuclei, it emit radiations. Why the nucleus become unstable? Because it becomes more heavy. Why it becomes more heavy? Because it becomes due to extra neutrons. When the neutrons becomes more inside the nucleus, the nuclei become unstable, and because of instability, it will emit radiations. If you emit radiations, then that respective atom is called radioactive atom. Okay, so there are some elements that are radioactive. Okay, keep in mind that most, not all, okay, isotopes are radioactive. They are radioactive. They emit radiation. Most of the isotope of naturally they emit radiations. Okay, they emit many type of radiation, like X-rays. Okay, like X-rays, like gamma rays. These rays, they are being emitted by these type of radiations. Is that clear? And nuclei, why emit radiations? Why some atoms emit radiations? Because their nucleus becomes heavy. And why it becomes heavy? Due to extra neutrons. Due to the presence of extra neutrons, the nucleus become heavy, and as a result, it emits radiations. So let's suppose, let me give you another example related to carbon. This is carbon. Carbon also have 3 isotopes. Okay, 12, 13, and here it is 14. 6, 6, 6. Okay. Now, if you see this carbon, which is present on Earth up to 98.9%. It is present on Earth 98.9%. Okay, on Earth, on this globe. Okay, and if here the mass number is 12, and atomic number is 6. So neutron number would be 12 minus 6, 6. Okay, neutron number would here also be 6. Okay, so it is the normal carbon that are being used. It is present everywhere. Okay, here this carbon which is present on Earth up to 1.11%, very small amount. Okay, its mass number is 13, atomic number is 6, and neutron number would be 13 minus 6, that would be equal to 7. So 7 is the atomic number, or sorry, neutron number of carbon 13. Okay, sometimes we usually write it as carbon 13. Okay, isotope, name of the isotope is written like this. Okay, we usually specify their mass number of the isotope. Carbon 12, carbon 13, here carbon 14, carbon 14. Okay, this is present very small in traces. Traces means negligible amount, very less amount, negligible, very less amount. Okay, less than 0. Is that clear? Now here its mass number is up to 14, atomic number is 6, so neutron number is equal to mass number minus atomic number, and 14 minus 6, it would become 8. So here neutron is 8. Okay, so here definitely logically nucleus of this carbon or mass of this carbon is more, that is 14. So this carbon is more heavier than carbon 13 and carbon 12. Because of its heaviness, what will happen, that its nuclei of this carbon will become more heavy, and because of its heaviness it will become unstable, and due to instability what will happen, it will emit radiations. So this carbon atom is the radioactive isotope. Why radioactive? Because it emits radiations. Why it emits radiations? Because its nucleus is more heavy, is unstable. Its nucleus is unstable. Why unstable? Because its nucleus is heavy. 2 extra neutrons are present in this. So 2 extra particles are present. Because of the presence of 2 extra particles that are nucleons, what will happen? The nucleus of this carbon atom will become unstable, and due to instability it will emit radiations, and we call this isotope of carbon as radioactive isotope. Okay, so this is the concept related to the radioactivity, and you can find the neutrons of each isotope by deducting, by minusing the atomic number through their mass number. Is that clear? So another example related to the isotope is about neon. Okay, neon symbol is this. Okay, neon. Okay, neon is a noble gas. Okay, and it is present in 8A group. 8A group are called noble gas. Okay, why? Because they do not react. So there are 3 isotope of neon. Okay, one is 20, 10, 21, 10, and 22, 10. Okay, let me clean this for this one. Okay, so there are 3 isotopes of neon as well. Okay, now this neon is present up to 90.5% in atmosphere. Okay, it is a gas. Atmosphere it is present 90.5%, and this isotope, it is present up to 0.3%, very less amount, and this isotope is present up to 9.2%. Is that clear? So this is a percentage composition, or this is the presence of neon in the form of percentage on this earth. Okay, so here if you see their mass number is 20. Okay, and here atomic number is 10. So the neutron number would be A minus Z, mass number minus atomic number. So here 20 minus 10, neutron number would be 10. So it is the normal neon,
which is present up to 92.5%,
and it is in abundance. Okay, we say that this neon, this isotope of neon is in abundance. Okay, it is present in large amount. This neon second having mass number 20, atomic number 21, and here neutron would be 21 minus 10, it would be 11. So here nucleus is heavier. Why? Because one extra neutron is present. Here neutron is 11, here neutron is 10. So this nuclei is a little bit heavier. So it will also be unstable. And because of instability, it will emit radiation, and we call this neon as radioactive. In the same case, if you see the mass of this neon, it is 22. Atomic number is 10. So definitely neutron number will become 22 minus 10, and it will become 12. So this is the nuclei of this neon is more heavier. Why? Because its neutron number is more. So 2 extra particles are present in the nucleus of this neon. 2 extra particles are present in the nuclei of this neon, and here 1 extra particle is present in the nucleus, in the nuclei of this neon, and here the particle atomic neutron number is 10. So what will happen that because of the presence of 2 extra particles in the nuclei of this neon, what will happen? The nuclei would become unstable, and because of instability it will emit radiations. So this neon is, we will say that this neon is radioactive. Radioactive means that it emits radiations by its own, emit rays by its own. Is that clear? So this is the concepts related to the isotope, and I hope that you have understood. Let me solve another example for you. In your book, the example is related to the vanadium 50. Okay, vanadium. Okay, vanadium have 2 isotopes. One is vanadium 50. Okay, 5023, and one is vanadium 5123. So here, if you see this vanadium, mass number is 50 and atomic number is 23, electron number is also 23, keep in mind. So neutron number definitely would be 50 minus 23. So 50 minus 23, 27. It would be 27. Number of neutrons here would be 27. In the same case, if you see this vanadium 51, which is also right, like we usually write isotope as vanadium 51. Okay, here vanadium 50. We write the full name of the isotope and then hyphen, and after that we write the mass number of the isotope. Okay, usually we write like this. We also write isotope in this way: mass number on the top left and atomic number on the top right. Okay, so let's calculate the number of neutrons of this vanadium. Here mass number is 51, atomic number is 23. It means proton is 23 and electron is also 23. Okay, is that clear? Both the number of neutron and electron, they are same. So chemical properties of these two elements are same. The difference is their physical property. So here neutron would be 51. Let's write the formula for you, that is A minus Z. So 51 minus 23, neutron would be here 28. Is that clear? So here one extra neutron is present in vanadium. Okay, so this is more heavier. We will say that this is more heavier, more denser. Okay, and it is radioactive, and it is radioactive as well. So there is radioactivity is a physical property. Okay, physical property of the atoms. So it is it is radioactive, and this is not radioactive. Why? Because extra neutron is not present. Okay, So extra particles are not present inside the nucleus. So this is their nuclei are stable, but nuclei of this vanadium is unstable because of extra particle, extra neutron. So it will emit radiations. Is that clear? So this is the physical property, heaviness and density, and in terms of radioactivity. Okay, keep in mind, again I will repeat that the chemical property of elements, chemical properties of atoms, it depends on number of electron, or we can say it depends upon atomic number. Okay, atomic number, Zeit. Is that clear? Chemical property depends upon the number of electron, while the physical property it depends on mass number. Okay, what do I mean by physical property? By physical property I mean the density and the ability to emit radiation, that is radioactivity property, radioactivity. These are the physical properties, okay, of the elements. I hope that you have understood the concept and try to practice calculating how to calculate mass number and neutron number of isotopes.